Okay, let's try this again. Okay, chapter 6. This is what we're going to spend the majority of this first unit on, sets and counting. This is from your textbook. It just talks about like what are sets, why do we do it. Anytime we group things together, we're talking about sets. Today's a lot of definitions, so please pay attention, ask questions when you have them. So what is a set? A set is a well-defined collection of objects, and that's really, really important that it's well-defined. If it's very vague, then it's not a set, okay? Gosh, I wish anything worked for me anymore. We usually label them with uppercase letters. Elements are the objects of a set, so that's what's in a set, and we usually label them with lowercase letters. And so again, when you're writing your notes here, 1, pause if you need to, if you're not getting it written down before I move on, and 2, you don't have to write every word of this as long as you know what it means, right? So if this was set A, this is one way that we can write set A. Set A, we call this roster notation because you're just listing out the set. And we would read this as set A consisting of the first 3 letters of the English alphabet. Or you could say set A that has the elements A, B, and C. Okay? So what if I asked you to write set B consisting of all the letters of the English alphabet? Well, you might be groaning right now because you're like, do I really have to write all 26 letters out? And the answer is no. You could do this. Maybe this will work now. Oh, it did. Okay. Set B, and you might have to practice doing these because we're going to use them a lot in here. We don't have to write all of them. We could just write like A, B, C, ... and then the last one, which is Z. Okay? That's roster notation. The other way that you can write sets is set builder notation. We've used set builder notations before when you just list a rule. We use it for domain and range. That's a set. You just list a rule. And so this is an example of set B, all the letters in the English alphabet written as set notation. And so you can just use a variable, usually use X, but you can use whatever, and then you just put the restriction on it using words. Okay? Oh, why I can't get that to move. All right. Other notation, other symbols we're going to be using. This little symbol here, we use that as an element of. So we would say that A is an element of set A. And to draw that, or you just like, I always just think of it like making a C and then putting the line in the middle. And if something is not an element, A is not an element of set A, is how you would write that. So, true or false, if A is the set 1, 2, 3, 4, 5, then 3 is an element of A. Well, we can look up here, and 3 is in set A, so that would be true. B, 6 is not in here, so 6 is not an element of A, and we actually it would be correct if we said 6 is not an element of A. Okay? This one we're going to talk about in class, but what is a set and what is not a set? So I want you to read those and be ready to discuss that in class so we can kind of make sure we understand the definition of a set. Other things I want to get through here, set equality. So again, another definition. 2 sets A and B are equal. Written A equals B if and only if they have the exact same elements, right? Pretty much like anything in math class, it's equal only if they're exactly the same. Sorry, I'm trying to move that out of the way. So look at this example. It says, let A, B, and C be these sets. And again, I have a little mistake here. Get used to that if you haven't had me as a teacher before. I'll try to fix that. Set A is A-E-I-O-U. Set B is A-I-O-E-U. And set C is A-E-I-O. Are any of these sets equal? Why or why not? Hopefully, you think that A and B are equal because they have A, They both have E, they both have I, they both have O, they both have U. So we could say that set A equals set B. But set C is not equal because it's missing an element, right? So I'm going to show you what the book said on this because I just want to make sure we agree on the that we agree on the notation here before we move on. So it says A equals B because they contain the exact same elements. Note that the order doesn't matter as long as they have the same one. And we could also say that A doesn't equal C because U is an element in A, but U is not an element in C. And we could say the same thing about B and C. And so again, just kind of getting used to reading that notation and understanding what it means. Subset, okay? So maybe you noticed that C had everything that A had in it, but it wasn't actually equal. That's called a subset, okay? So a subset, I don't know what's happening to my life. Okay, if every element of set A is also an element of set B, then we say that A is a subset of B. And we would write that using this notation. A is a subset of B. That's what this means, is a subset. Like A is contained in B. So if we go back over here, every element in C is also in A. So we could say that C is a subset of A. We could also say that C is a subset of B because A and B were equal, right? Using that idea, we can say to define what equal sets are, two sets A and B are equal if and only if, can you see my struggles here today? If and only if two things. One, A has to be a subset of B, and two, B has to be a subset of A. And think about what that means. Everything in A is contained in B, everything in B is contained in A. And if that's true, then they're equal to each other. Okay? Oh, I jumped ahead here. Look at example 3. Are any of these subset of one another? Yes. We said that already, right? C is a subset. We could actually even say A is a subset of B, but they're actually equal. Equal is a better way to say that, in my opinion. And then what if we threw in this? Set D. D is not a subset of A, B, or C because it has X in it, right? And X is not part of A or B. So if there's an element in it that's not there, it's not a subset. So we could actually say here that D is not a subset of A or D is not a subset of B. Okay? A lot of notation, a lot of vocab. So a proper subset. Okay, so like I said, if A and B are equivalent, they're also subsets of each other, and so that can be kind of confusing. So a proper subset is if A and B are sets such that A is a subset of B, but A is not equal to B. We say that's a proper subset. Like A is contained in B, but is not exactly B. Oh yeah, so I covered all this up, I guess. So this is kind of important to write out, I think. So it says A is a proper subset of B if two things are true. If A is a subset of B, and two, what this is saying is there exists at least one element in B that's not in A. How do we denote that differently? Right here. Notice the difference between this. This is just a subset, which means they could be equal to. Think about like less than or equal to, greater than or equal to signs. This one is just a subset. A is a subset of B. A is contained in B. That's what I think about it. Okay? So, look at this one. It says, let A equal the set 1, 2, 3, 4, 5, 6, and B equal 2, 4, 6. Is A proper subset of B? Is B a proper subset of A? What's going on here? So we can see here that every element in B, 2, 4, 6, is also in A. So that means that B is a proper subset. So we could say B is a subset of A because everything that's in B is also in A. We could not say it the other way, right? A is not, if you wanted to say this, A is not a subset of B because everything in A is not in B. We're not going to put the line underneath it because we know they're not equivalent. Okay, so that's the difference between those. Oh, look, I just kind of said that. Real quick, the book likes to point out little things that people get confused. One, to me, these are like, not like less than, greater than, but the same idea of like this means proper subset, so it just contains it, it's not equivalent. This one could be equivalent to it. Like this is if you didn't know for sure, or you know for sure they are equal. This is what you use. And then this is the real reason I put this up. This is when we talk about an element of. And so again, you don't necessarily have to write this all down, but I just wanted to show you this in case you don't read your textbook, is what we use these to talk about it contains it, right? I like that word. Like A is contained in B when you're talking about the actual sets. But when you're talking about the elements in the set, you use this, right? This is used for the elements, which is easy to remember because it looks like an E, right? Okay. This is my last thing, I think, right? Let's check. Oh, no, two things. Empty set and universal set, okay? Empty set is the set that contains nothing, no elements, and we use this like 0 with the slash through it. Many people use this symbol to mean no solution, but it actually is the symbol for empty set. And the empty set is a subset of every set, and that's because the empty set contains nothing, and so that means that there's something in A that's not in it, so you can say it's a subset. If you were writing it out with notation, you would write it like this. All right, that's not the same as just the empty, it's not the set of 0 that has the number 0 in it. 0 is a number, right? And so we're going to list all the subsets here. We're going to do this one in class, but see if you can do that. How many subsets do you think this has? And we'll do that one in class, but I want you to try it. And then the last thing I want to say, and we'll do example 6 in class as well, is the universal set. The universal set is the set of all elements of interest in a particular discussion. Now that means the universal set changes for each problem, but the universal set is like the complete set. And so, again, I kind of said this in the book. I need to move this guy out of the way. It is the largest in the sense that all sets considered in that particular problem or that discussion are subsets of the universal set. And so example 6 kind of shows some of that. And again, you can kind of think about this of what would the universal set be in each one of these scenarios. And then that's what we'll start in class. Again, a lot of information today, but we got to lay the foundation so we can do this stuff, okay?